Okay, so hope everybody had a good weekend. This is our third focus activity. I do have a fourth one printed and ready to go, so don't turn these in just yet. At the very least, we're going to have 4 in the set. I'm hoping to have a fifth, but it just depends on the amount of time, because next week's going to be kind of an unusual week. This weekend, you have a 3-day weekend, so I don't see you Monday. And then I won't see you next Friday because I'm going to be taking care of something. So that only gives us 3 days next week. And then after that, we're all ready to finals week, which is going to be basically review, district assessment, and your finals. The only thing I want to go ahead and say, this Thursday, what's going to be passed out to you? Not in here. What's that? During 7th period? Progress reports, okay. So some people are unfortunately failing. This class isn't actually doing too terribly bad. I think there's only a handful of folks. But for those folks, we only have so many opportunities left before the semester, is just done. Okay, we got less than 3 weeks, and we're going to be finalizing grades. So these last ones, like the homework assignments, quizzes, especially the test, please make sure that you're preparing for them. Take time outside of class. I know we're all busy, but it really, really, needs to take place. And if you have questions, come on in. Let me help you. Okay, had a few people come in this morning during tutorials, but that being said, this one should hopefully be a good grade because all you got to do is hang on to them, work together, and turn it in. Okay, so it says a vertical flagpole is attached to the top of a building. So I already started constructing the diagram. So, of course, here's the ground, the building, and then I've got my little flag right there. Okay. A man stands 400 feet from the base of the building. From his viewpoint, the angle of elevation to the bottom of the flagpole is 60 degrees. To the top is 62.5 degrees. Determine the height of the flagpole. All right, so our ultimate goal is to get the flagpole. So I've already seen 2 different classes today, and I've already seen 2 different ways of solving the same problem. And one of the methods was actually really clever, the way she did it. But what I'm interested in is how somebody in here would solve it. So I do have the random number generator pulled up, but I will go ahead and ask, is there anybody who would like to volunteer? Satish? You sure? Okay. Now, let's just see who Satish went to bat for. Who's 34? Oh, that is you. It's fate. There you go. All right. So Satish is helping himself out.
Okay.
All right.
Do you want me to explain it, I guess?
Sure. Kind of walk us through.
Okay, so we know the man is here, I guess.
That's a tall guy.
Yeah. It's not drawn to scale.
Yeah, not drawn to scale.
Okay, so the length here.
Is he jumping?
Here? No, he's just let's just say this is the ground.
Okay.
This is 400.
He's so happy to be doing math. That's why.
400 feet. So
Okay.
what I would do is draw 2 triangles, 2 separate ones. So just to make it easier, you can draw one right here and then one right here. So
Okay.
angle for this one, which it says it's from the bottom of the flagpole is 60 degrees.
Oh wait, but the man isn't standing or isn't looking at the flag from the ground.
Okay, we're just gonna erase him.
No, because he's 6 feet in the air.
Okay, well, there's no man anymore, so it's and then we can draw another one here, which is 62.
Yeah, so I see what you're saying, Jack. Even though, the man would be using his line of sight, the angle measures would still be the same. And he's still 400 feet away. So, yeah, whether we did it to the ground or to him, yeah. And really, it'd be negligible because he's 400 feet away. And, let's just say, for example, if this is a 4-foot tall guy. What percentage is 4 of 400? 1%. So, see, it's, it's very, very small if that were to be included. You see what I mean? So, there you go. Okay.
So, the height of the triangle, we could just do, the length of this triangle is subtracted by the length of the other triangle. So,
okay. So, you're talking about finding the height of both?
Well, yeah.
Okay.
Height of both and then subtracting them at the end. So, here's the 60.
Okay. So basically, one triangle's height represents the building and the flagpole together, while the other triangle's height just represents the building. Okay.
So, yeah, we can use this. So we can do that by using our tangent function, which would be 10.
Okay.
62 is equal to the opposite over adjacent, which it's 400, so we can get rid of this and multiply by 400.
Okay. So that's going to represent the entire height.
Yeah, the
Okay.
entire height. And then we can change that by subtracting 400. Oh, I don't know. This can fit tan of 60. But that should get us our answer because we're subtracting the two. Total height minus the building height.
And is everybody okay with what he's doing? Anybody confused by the expression? Okay. And he's absolutely right. All we got to do now, type it in, and we should be able to find exactly what the height of the flagpole is. So 400 tangent, 62.5 minus 400 tangent of 60. All right. Yeah. There you go. That is exactly right. Very good. Okay. So the flagpole, let's say it's about 5.6 feet. There you go. Okay. Like I said, there was a lot of, there have been a couple of other people who solved it in some really interesting ways. My first idea was to do the exact same thing, find the two heights and take the difference. Some people immediately recognized that this smaller triangle is a 30, 60, 90. So you already have the height. You could just say 400 times the square root of 3, because that's across from 60, right? Okay. Or there was another person in second period who went ahead and said they went ahead and used the law of cosines, I believe is what they did. Or no, law of sines. I'm sorry, law of sines. And I thought it was really interesting that all the people had these different perspectives on that. Okay, but any questions? Are we good? Okay, so go ahead and put that somewhere safe. You should have 3 of those by now, and we'll be turning them in at some point. Okay. So let's go ahead and wrap up the other inverse trig functions lesson that we were looking at. Now, one of the things I did provide you today is this. This is going to be the basis of our next unit. These are all the trigonometric identities that we're going to be looking at. So tomorrow, we're going to start talking about these in a lot more detail, and I'm going to go ahead and choose random ones and go ahead and prove them to you. I definitely won't prove all of them to you, but if you know how to prove one, you could probably go ahead and prove the rest. Sometimes I'll do it algebraically, sometimes I'll do it graphically. It depends on the identity. But we're going to go ahead and start working on those. And the plan as of right now, we're going to have a activity on Thursday. Friday, of course, is going to be the test. But the test will not have trig identities on there. In fact, the 2 parts of the test are going to be inverses of trig functions and what? Graphing trig functions, yes. In fact, you remember last week where we had, I don't remember, did you have a sine or a cosine quiz to graph? Okay, so yeah, cosine because there were 2 different versions of it. But on the test, you're going to have the exact same format. You're going to find me the same information, fill in the table, but it's going to be for one of the other 4. It won't be a sine or a cosine. And that's really what the test is going to be about. Okay, so this is what we started talking about on Friday. So the top 3 rows are a little bit of review here. Remember, what can I input into an inverse trig function? Is that an angle or a ratio? What do you guys think? What can I put into an inverse trig function? It is a ratio. Now, the answer to an inverse trig function is going to be an angle measure. So we've got the domain and the range listed here. So whatever the ratio is for both sine inverse and cosine inverse, it has to belong to this interval. If it does, well, then you can get an angle measure in these intervals. Remember, sine inverse was restricted to quadrants 1 and 4. Negative pi over 2 to pi over 2 with the boundaries included. Cosine inverse was restricted to 1 and 2 with the boundaries included, 0 and pi. Now, tangent inverse, you can plug in any value to the inverse tangent that you want. any number you could possibly think of, and it's going to work, except, of course, imaginary. And then your answer is going to be restricted to quadrants 1 and 4, just like sine inverse. But what was the key difference between sine inverse and tangent inverse? Tangent inverse couldn't do something. There you go. Tangent inverse can include those boundaries because tangent at pi over 2 or negative pi over 2 is undefined. Okay. And then we're not really talking about these. I just went ahead and gave you the rest of the information. If you were curious, or if you're moving on to calculus, this will definitely be of use to you later on. But I haven't shown you the graphs or anything. But if you were interested, what ratios can I plug into cosecant inverse? Well, it has to be everything from negative infinity to negative 1 or 1 to infinity. And then your answers can only come from these intervals here. Okay, so if you wanted to look into that, in a little more detail. We're solving these other inverses by taking the reciprocal. Okay, so the reciprocal of secant cosine, the reciprocal of cosecant is sine. We're simply taking the reciprocal of the trig function and the reciprocal of the ratio. The only one we have to pay a little bit of attention to is going to be cotangent inverse. So if the ratio is positive, well then we'll just take tangent inverse of the ratio, or reciprocal ratio, that is. If the ratio is negative, then we'll do the same thing, but we have to add pi to it. And that's actually very similar to the number 18 on your paper that you may have looked at earlier. Okay. And one other thing we talked about on Friday, what does that little word arc mean? Yeah, it's just signifying inverse. That's all it is. It's a new way of writing it. So if I wanted to show cosine inverse, but I didn't want to write the notation with the negative 1, I could just put the word arc in front of it. It means the same thing. Sine inverse is just arc sine. Okay, and same for all the others. Okay, now I think we started working some examples. Did we get through 3? We did? Okay. So why don't we move on to 4? I want cotangent inverse of 1/2. And actually, we were just talking about cotangent inverse being the one inverse we want to be very careful about. Is that ratio positive or negative? It's positive. So because it's positive, back here on the front page, I know this is all I need to do. I need to take tangent inverse of that reciprocal. And we should be able to get the answer. Okay, so I'm going to come back over here. So cotangent inverse of 1/2. I'm going to say tangent inverse of 2 over 1. Now, I went ahead and put it as 2 over 1 because we're about to create a triangle, and I need the sides. But had you put 2, that wouldn't have changed anything. Could I also have put arctan? Yeah, it doesn't matter. I just went ahead and kept it the same notation. So let's see here. What quadrant would this inverse tangent Stephanie put me in? 1 or 4? Why 1? It's positive. There we go. So I'm going to go ahead. Let me use this over here. I'm going to sketch my triangle over on the side. Oops. Okay. So we're in quadrant 1. So I'm going to connect it to the x-axis. So this is the answer I'm looking for. Okay, that reference angle theta. What's tangent's ratio? He's always what over what? Yeah, opposite y over the adjacent x, right? So this is y, this is x. So I know this would be 2, this would be 1. And again, another problem where we don't need the hypotenuse, but we might as well go ahead and find it anyway. What would it be? Root 5. Okay. Does anybody want me to run through the Pythagorean theorem to show that's what we get? Okay. Well, we can recognize immediately this is not a what? Yeah, it's not a special right triangle. Now, the way it's going to work on the test, if you're working one of these problems and it does turn out to be a special right triangle, you'll write your answer in radians because we should be familiar with what those angles are. If it's like this one, we're just going to leave my answer in degrees because you won't have a calculator, but you'll have the protractor. So I need to go ahead and recreate this triangle right here, but I need to actually go ahead and measure it out. So we don't have to convert anything. We just have 1 and 2 centimeters. In fact, who would like to come on up and show me how to do that? Who's been sitting there thinking, man, that looks fun messing with those technology? So Dylan? All right. So Dylan's going to help me out on this. We'll see how close we get. Okay, so in inches, cool.
Yeah.
Okay, so there's 1 inch on the base. Okay, and let me go ahead and connect it for you. So we'll have a pretty straight line. So I'm going to start here at the origin, shoot through that dot that you put. Okay. Now we're going to place the crosshairs right there. And what do you think?
That's looking like 64.
64 degrees? Okay. Would you guys agree? All right. So 64 degrees. I'd say that's a good answer. Now, you won't have your calculator to help confirm, but let's see how close we actually got. I'm going to go back to the original. Cotangent inverse of 1/2. So let's see here on my calculator. Trig, cotangent inverse is the bottom row of 0.5. Okay, he said 64, and the actual answer is 63.4, so that is almost perfect. That's a very good job. And what am I going to do on the test because you don't have a calculator? Yeah, I'm going to go ahead and give a range 5 points up, 5 below. So hopefully, even if your measurement is a little off, you'll still be, as I call it, in the neighborhood. It should still be acceptable. Okay, is anybody having trouble measuring these angles? Okay, let's try another one. Okay, don't think we have another one where we measure, but I think our last 2 problems are going to be, I think they're compositions, am I right? Yes, okay. So let's see here. Find the exact value of cosecant of cotangent inverse of 1/2. Okay. Now, if I were to go ahead and start trying to evaluate this problem, I'm trying to find the final answer. What would I do first? Okay, start with what, Christian? Okay, yeah, always start with the inside. But do you notice anything?
The answer.
Yeah, isn't the inside function the problem that we just saw? Okay, so let me recreate this triangle real fast because I want to show you something. Okay, so we know we were in quadrant 1. Okay, we have the right triangle. In fact, we found that the answer was, what was it, 63.4? Exactly. Okay, and then we know that tangent, or even if you want to use this, it was x over y, so it doesn't matter. We ended up with the square root of 5. But here's why I've been emphasizing so much lately. When you plug a ratio into an inverse trig function, the answer is a what? An angle measure, right? So let's say we had been solving this problem and we didn't know previously that the answer is 63.4. Do we need to know the value of 63.4 in order to solve the problem? No. Because think about it, big picture, cotangent inverse, if I plug this ratio into cotangent inverse, the answer has to be an angle measure. Okay? And it doesn't matter what that angle is, because what if I plug an angle into a trig function? My answer should be a ratio. So I know that plugging an angle measure into the outside function, it should be a ratio. So what I'm trying to show you is that if you have a problem like this, you wouldn't actually need to go ahead and figure out what the angle exactly is. I would just have to use that angle to now figure out the final answer. What's cosecant's ratio? It's what over what? Okay, it's always the hypotenuse over the opposite, right? So using this angle, again, whether it's theta or we know the actual measurement, doesn't matter. The opposite 2 with the radius square root of 5, that should be my answer. Okay. And again, if you realize that, it actually saves yourself a little bit of work, a little time and effort. And let's see if we're correct about this. We had cosecant of cotangent inverse of 1/2. So I'm going to come on over here. Okay. So cosecant of cotangent inverse of 0.5, the 1/2. Okay. And of course, it's going to give it to me as a decimal value, right? Remember, we said the answer was what? Yeah, we said it was the square root of 5 over 2. Bam. So see, it still gives me the exact same value, so we know you're correct. That's the only thing you're not going to be able to do on the test Friday. You won't have the calculator to kind of confirm your answer. So you'll kind of have to, just go with, what you feel is right. Okay. Let's try this next one here. In fact, I believe it's our last one. Find the exact value of secant of cosecant inverse of -2. Okay. So for right now, forget about the secant. Or in fact, would you guys like to try this one on your own? Okay. Well, try it on your own. Let's see what happens. Okay, what's the worst that could happen? You get it wrong, and that's okay. At least next time we'll know what not to do. Or you never know, you could get it right. What do you think, 2 minutes? Let's go 2 minutes. Okay. I think that'll be plenty of time. Hopefully. And this is the last problem, and I've got 10:37, so we might as well kill a little bit of time anyway, because we don't get out of here till 52. Thirty seconds. Okay, by show of hands, how many people believe they have the answer? Okay. So, a handful of people. Going up. Connor, what do you think?
2 root 3 over 3.
2 root 3 over 3. What do you guys think? Okay. Let's check it. Good. That seems to be what other people are getting. Now, let's go ahead and start. Forget about the secant. If I want to evaluate this, I'm going to say sine inverse of -1/2. Would you guys agree? Okay. What quadrant would I be in? 4, because it's a negative ratio. So let's see. Here's the fourth quadrant. Okay. So I'm looking for this guy right here. Now remember, sine is always the opposite over the hypotenuse, the radius. So this would be 1, this would be 2. The negative would have to be on the 1, because y is negative in the fourth quadrant. And where'd you get root 3 from? There you go, because if I use the Pythagorean theorem, that is going to be square root of 3. Now, again, we know, because it's a special right triangle, cosecant -1, or should be cosecant inverse of -2 is actually what? -30 degrees, right? Okay. Now, it happened to work out on this one, but again, that's my point. Do we really need to know that's -30 in order to solve the problem? No, because I'm going to plug an angle in here, which means that my final answer should be a ratio. So using the same angle, what's the secant of that -30 degrees? What's secant's ratio? Remember, it's r over x, right? So r2 over x, the square root of 3, and then we had to what? Rationalize it. So 2 square root of 3 over 3, that is exactly what Connor told me. Now, how many people got that right? Well, now there are way more hands going up. So I'm kind of curious, when I asked how many people had the answer, why didn't all those hands go up? Were you not confident? Okay, even if you're not confident, you know you got an answer. Okay, be confident. You know, but this is the answer. Okay. So like next time, you know, if you're not sure, if I said, okay, you know, Dylan, what's the answer? 2 squared root of 3 over 3. You know, with, you know, be aggressive. And then I might go, oh, you're wrong. Then I'll go, okay. Or he might be right. You don't know. Okay. But, you know, be confident. You'll do it. All right. Well, that is all I got, unless anybody has any other questions. Now, I am not going to give you a homework assignment over this. What I am going to be doing, I believe the homework assignment is already posted to the website. I'm just going to go ahead and post the answers to that in case you were looking for a little extra practice. I'm not going to be taking it for a grade. I don't believe I've posted that yet, but I will go ahead and get that done sometime today. And then tomorrow, we'll go ahead and start on those trig identities that showed you earlier. Okay? Let's go ahead and get the calculators back up to the front, please. And if you have a protractor, if you could put that back in the box.